Hello and welcome to Berkshire Guitar Amplifier Repairs. We're going to be looking today at the Engl Powerball amplifier. Not an amplifier I'm very familiar with, although I do know something about this amp in that the printed circuit boards are all component side down, track side up, and virtually impossible to get the boards out. So if you want to do any repairs to these amps, they are exceptionally difficult to work on. So I'm not really looking forward to this one at all. Anyway, I promised the customer I'd give it a college try, and he's going to scrap it if I can't fix it, so it's worth a go. The problem is it lights up, all seems to be okay, no sound whatsoever coming out the speakers, so we're not getting any power through the amp for whatever reason. So I think without much delay we'll take the chassis out and get it up on the bench and see if we can find out what's going on with the amp. Fingers crossed we're able to fix it. Okay, so I've put two valves in to the central positions and connected the bias meter to each. We're switched on and the standby is on, and you can see that we have HT on both valves but no current through either valve. So something is wrong here. There are only a couple or three possibilities. One is that the bias voltage is way too negative, so instead of having, I don't know, minus 30 volts or something, there's minus 60 volts on there, turning the valves off completely. The other likely candidate is that the screen resistor has gone on one or more of those valves, or the screen voltage isn't present somehow. That would turn the valve off. What else? I suppose the other possibility is that the cathodes aren't connected to ground somehow. A little bit more unlikely that. So maybe screen resistor. I'll measure the bias voltage and see what that does. Right, I want to take a couple of measurements on this amp to see what's going on, and what I will do is measure the HT. Here's one of the HT caps here, and the negative lead from it goes to this point here, and the positive lead goes into this second red one up here. So I'm just going to measure to see if we've got HT in the circuit. These are all the same ground, so I'll just go onto there and this one, and we've got HT there, 480 volts. There's another HT cap here. This will be a bit further downstream. This is 47 microfarads at 500 volts. So let's just see what we've got across there. Here's the positive side. There's the negative side. Interesting. Positive, negative. There's nothing across that cap. Oh well, 0.1 of a volt. Oh well, that's interesting. Right, well, that cap is downstream of the main one, so I'm guessing that something's happened to the feed to that cap. That's normally fed via a resistor. Let's see if we can see what's happening on the power valves. They are, I'll put this over this side for the moment, hopefully you can see that. Yep. I'm just going to quickly measure around the power valves to see what we've got here. So I'm going to clip my negative lead onto the chassis. I think I'll go onto this valve because I've actually got a valve plugged in here. So what we've got here, oh, that's probably the heater. Ground there, nothing there. That's the heater as well. Looking for some HT. Oh, that looks like I've got a bit of HT there. That's probably pin 3. 1, 2, 3. 2 and 1. And look, we've got some negative bias voltage there. That's the minus 48 bias. So what I'm not seeing is any screen resistor, any screen voltage. HT bias, we've got everything there apart from screen. So okay, what am I thinking? I'm wondering if maybe this capacitor is the one that's providing the screen resistor. Now I'm looking at this capacitor and I don't like the look of it. There's a little bit of leakage. I'll have to move the camera for you to see this. I'll take it off the overhead in a minute and let you see. There's some leakage coming out of this capacitor. So one possibility at the moment, I'm thinking, hypothesis, is that that cap has failed and maybe pulls too much current through its feed resistor and open circuited the feed resistor. Now I'm just looking here. How much of this can you see? Let me see if I can zoom in a bit for you. Okay, so I'm wondering if we are going to get a little bit lucky here. These boards are a complete nightmare to take out, to even have a look underneath. Really, really difficult. So follow me through on my thinking here. Right, I'm going to turn this off actually so that nothing's on. Right, here's the HT here on this red one here. Okay, the track goes along here. These are probably the HT diodes under here, these dump dump dump, and see that track there goes to that pin there, which then goes to the that's the negative side of that capacitor, not, oh no, that is the positive side. Oh, that's very oh yeah, look at that, that's marked plus V minus. I assume that was the plus side of the capacitor. Okay, so yeah, this is the positive side of the capacitor, right? So HT comes along here, goes through mysterious component X and into the positive side of this capacitor, and we've got no voltage here at all. So mysterious component X will almost certainly be a feed resistor, and that has probably gone open circuit. So I'm just wondering if we can get incredibly lucky here, change that capacitor. I'll go and see what the value of that resistor is, hoping that there is a resistor underneath there, and then I can put a resistor on the top here and maybe it'll come back to life, because we do not want to be taking, let me just zoom out again for you, do not want to be taking this board out if we can avoid it. It's these boards would have to come out. As you can see, it's all held down here by these connections here. We've got these multi-ribbon cables going to this side of it, so at the very best, or we have to take this. Oh, no, I'm just wondering how on earth you would do anything on this. You might just be able to lift it up fractionally to see underneath. I don't know. Short of that, you'd have to be desoldering all of these wires here so that you could get the board up this way. Really shockingly bad design again in terms of any kind of maintenance. Anyway, I'm going to give this a college try by swapping out that capacitor, going and seeing what that resistor is, and then putting one in on the top side and just see if we get lucky. Right, here we go. I will change the cap, and to do that I'm just going to chop out the old one. Negative at the top, positive at the bottom. It's well glued in, that's to stop it vibrating and coming loose. So with a bit of luck we can just pull that off. That's good. So there's the old one. I'm not loving the end of that. I don't know what you think. Not looking great. So let's put a new one in. Here's the new one, a nice F&T 47 microfarad, 500 volts, and we'll pop a bit of hot melt glue on. I think I'll just chop these leads a bit shorter, they're a bit long. Okay, now pop a bit of hot melt glue on there. There we go. And before that gets too set, we bung the capacitor in. Negative to the top, positive to the bottom, that's right. Now all we need to do is make a little kind of J hook of these leads here and we can solder onto the old stubs. I had a look at that capacitor, beg your pardon, I had a look at that resistor value on the schematic, and it looks like it's 470 ohms, but it doesn't say what the power of it is. Now, judging by the spacing on those terminals, it looks like, you know, quite a decent sized resistor to me. So I think I'll see if I've got a 5 watt or something knocking around in the box and put that in. Bend this around here like this. It's still very long, this one, so I'll just cut that off. Exactly what I didn't want to happen, a bit of wire fly off into space, but fortunately I can actually see it there. I'm just going to fish that out whilst I think about it. Don't want bits of wire floating around. There's the little culprit. Get rid of that. Right, now we can bend this around a bit better. There we go. Now we can give that a little bit of a solder. There we go. Great, so that's the new capacitor in. Now I'm going to take my life in my hands, and I think I'm just going to attach a bit of wire to these two terminals and bring them out here and stick a power resistor on here just to see if the thing comes to life. Okay, now here we are. I've got a 470 ohm 5 watt resistor in the box, and I've just tacked it across the open circuit 470 ohm resistor there. Whilst I was doing that, I noticed that you probably won't be able to see, but the track from this, where are we? Yes, from this side of the 470 ohm resistor and the positive of the capacitor loops across the board here, and you can probably see on this one there, to each power valve there's a pair of terminals like that. There's one there, there's one on this valve, there's one on this valve, and there's one on this valve. Now I believe those to be the 470 ohm screen resistors. So we're on the right track here with this screen voltage being down. That's why all the valves are off. So I thought I would measure the resistance between each of these screen resistors, and I'm afraid we've got another problem, because let me just show you one. There should be 470 ohms, so 470 ohms on that one roughly. I'm not really after anything exact. 430 ohms on that one. This is the one here which is low resistance, so that's 75 ohms, look, and this final one here, final screen resistor, is again 430 ohms. So we've got a problem with a screen resistor here. Now I'm going to have to take the camera off to show you this, because I think I can see some burning through the board on that screen resistor. So let me just do that quickly. Okay, again, not easy to see. Here's the screen resistor here, between here and here. Can you see that kind of shadow? Burning shadow there. That shows me that the resistor's overheated. Whereas we go along to this next one, look, and there's no similar shadow. And this is the one which has the low resistance. So we've got ourselves a bit of a problem here, because that resistor is not open circuit. Otherwise we could just tack a 470 ohm across it and we'd be out of trouble. We would just literally solder another resistor from here to here. The one underneath is open circuit, job done, but it's not open circuit, it's low resistance. So we have to get that resistor out somehow, and that won't be easy because we can't get to the board. So I'm going to have a think about that, and I will have a think about it and get back to you, because I'm sure as hell not taking this board out if I can avoid it. Well, I've formulated something of a plan of action. It's typical, of course, it's underneath here. It's not one of these ones we can get to nice and easily. That would be just too easy, wouldn't it? So I'm going to take this board out, which is not a big deal, and bend it back. And then, I tell you what, I'll do that and I'll show you what I'm planning to do rather than try to get the camera into the little narrow gap. So I'm just going to take off these nuts and this knob and nut, and then take this board out. Okay, there you go. I just took the board out and put it back here out of the way, and now we can see here's the offending screen resistor, and you can see quite clearly, I think, the burn mark through the PCB there. Well, you can probably see there aren't many options here. One would be to try to cut that track there and take a new resistor from here to here, but I don't really like that. There's not much distance between there and there in terms of, I don't know, any kind of arcing or anything. So I think the only other alternative, I mean, I could try to desolder these and push the resistor through the hole somehow, but that would just leave it hanging underneath the board. Again, that's not ideal, particularly with high voltages on it. So I think the only option, I think you'll agree, is to cut the track here and here to isolate this terminal here, and then bring a resistor out to here somewhere and take a wire from here to the resistor and here to make complete the circuit. So I think I'm going to do that. It's a bit drastic, but the customer's talking about scrapping this amp if I can't fix it, so there's nothing lost in a little bit of butchery here. So I will have a go at that and see if I can show you how I do that. At the moment I'm not completely sure how I am going to do it. Okay, well, the plan is to use a Dremel tool I don't very often use this actually, so I'm not sure if it'll work, to just cut the tracks here and here. So let's see if that'll work. Yeah. Oh, quite impressed with that. That works absolutely brilliantly. I should remember to use that again. Okay, good. Right, now I want to see if I can find myself a 470 ohm 2-watt resistor, so I'll go and grab one of those. Okay, yes, I had one in stock, 470 ohms 2-watt. I think I'm going to, I mean, the options are to solder it to here and leave this end hanging in the air here and put a piece of wire from there to there and a piece of wire from there to there. And that's okay, but the resistor will be flapping around a little bit. I think I'm just going to go straight across from here to here with the resistor and then bridge this gap here. So I'm going to get myself some sleeving to put on here, and then I think that'll make a little bit of a better job. Okay, here we go. I've got the resistor, so I'm going to go, I think I'll just tin that connection. Where are we? We're going to go from here. Down to here. I think since I've got the length, I'll go straight onto the valve pin there. And we're going to go down to here. There we go. What I now need to do is make a link between here and here. So that's the next job. And then we're ready for the moment of truth. Okay, I've got myself a length of wire cut to the right length and tinned. So I'm going to solder it. It's not easy actually, looking at this. solder it onto in here. Can just about get the soldering iron in there without burning those wires. It's like doing operations sometimes, this. Okay, yeah, I can tin that, and I can solder this onto here. Good, that went quite smoothly. Now I'm just going to bring it over to the same place as this resistor here. Turned out to be a bit more work than I thought, this. But it would have taken a good hour to take the board out, and maybe as long to put the thing back again. That's assuming you can do it. I'm not even sure how one would do it. Okay, so there we go. Right, let's just do a double check here. Capacitor is in the right way round, positive is down. Correct. We have got a link from here bypassing this cut to here. Correct. This resistor is now not in circuit, it's just hanging on that pin there, and we've put a resistor, 470 ohm screen resistor, from here to here. That should all be okay. Right, so we can turn on, you know, if this works it'll be a bit of a miracle really. I think I'll just pop this board back in, out the way. I'll just put one nut on there. Now what we're looking for, of course, is some current on these bias meters here. We're looking for voltage and current. So why don't I just do that live? If it blows up, well, there you go. So we plug in. HT off at the moment. Just let it warm up. And what we're looking for is current. We want some valve current. So I put the HT on. Oh, look at this! How nice is that? Oh yeah. Who's a happy bunny? Nice. So basically the valves are coming on and they're working. Awesome. So we'll turn off for the moment. Okay, so I thought I'd just turn the amp on and see if we have any sound coming from it. So I've plugged a speaker in, I've got a guitar in at the other end, and we'll turn it on. Watch these bias meters. We can see the bias is not quite right between the two valves, but I'm not sure of the situation regarding these power valves. I've only got two in at the moment, and the customer supplied them, so I don't know if they're a matched quad or anything. I'm not worried about that for the moment. Okay, I can hear nice reassuring noises coming out the speaker. Wow. Well, this amp is working. I've just realised that I didn't put this power resistor in properly. It's just been hanging down here all the time, so I'm going to need to do that. Quite lucky that didn't touch anything, actually, quite close to the chassis there. I got distracted with this other business, so I'll put that resistor in, and I'm very happy about this. I mean, this could have been a nightmare to fix, and just by having a little bit of luck about being able to see where that track went and looked like there was a resistor underneath it and all that kind of thing, allowed us to get ourselves out of trouble here without spending a fortune. Right, I'm going to put that resistor in properly, and then what am I going to do? I want to have a word with the customer about whether he wants a new set of power valves in here, or what, and then if he doesn't, I'll measure the valves and see if I can get a kind of roughly matched situation. To make a decent job of putting that resistor in, I'm afraid I'm going to have to take this board out. I just can't get to it. I could do it, but I think it would just be so much easier to give ourselves a bit of room here. we'll just take this out. I think it's held in by these little things now. Yep. There we go. Right, now we can hopefully see what we're doing and put this resistor down onto here. So I'll just desolder that. Mains is out, caps are discharged. We're nice and safe. Okay, let's take these off here. A bit like leaving a scalpel inside a patient. That I came very close to leaving all this hanging around inside there. Okay, so the sort of profile we want on this is this kind of thing. Something like that. I'll just tin those ends. It's always difficult on these videos to know how much to show you. Some people will get bored watching me put a component in like this, and other people will be shouting at the screen saying, "This is exactly what I want." Everyone skips over this bit. They just fast forward when the component's in. So I'm just going to tack that in there. And now I can do a proper solder job on here. That. And now I'll just go over this joint here again. Always a useful little trick that you just tack it in, give it a bit of stability, do the other joint properly, then go back and do the first joint. I'm going to push that down onto the board, which gives it a bit more stability rather than flapping around in the breeze there. Now we can put this board back in. There we go. Don't tighten these too much. A very light tighten. It's only plastic on plastic. You can easily strip the threads. And I don't over tighten pot nuts too much either. Just hardly putting any pressure on that at all. Pop these little screws back in. This is some sort of, I don't know, RS, what is this, some RS232, oh, it's a custom foot switch port. Ugh. Ugh. I don't want to know. I bet that's never used. I bet not one customer in 10,000 uses a custom foot switch port. There we go, done. Knob back on. Minimum there, minimum there. Dump, dump, that's done. Okay, good. Right, we're good to go there. So I'm going to give the customer a call, see if he wants a new set of valves. I'll report back to you. Okay, so now I'm going to show you how to bias the Engl Powerball. I've got it set up with a quad of JJ6L6s. The customer wanted a new set of tubes, so I've popped those in, matched quad, and I've got two bias meters set up. You don't need two bias meters, but it's quite nice sometimes to see what's going on onto the two central valves. So we'll turn on and then put the HT on, and we should see the valves start to draw current any moment. There they go. And we'll see what these new valves are doing. it's a 450 volt plate roughly, so we're looking for 43, 44 milliamps on the valves, and they are not going to make that. I can see that immediately. They're going up to 32, quite well matched as well, that's nice. So we're going to need to bias this amp. I never biased one before, so I actually looked up someone else's YouTube channel to see how to bias it, because it wasn't at all obvious. So to do that I'm going to need to flip the amp upside down and put it on my wooden stands here, and I'll rejoin you then and I'll show you how to bias the amp. Okay, I've got the amp flipped over onto its stands. I'm not surprised I missed it, because this is the bias adjustment here, this little hole here next to the mains transformer, and just pop a screwdriver in there. Not the ideal screwdriver this, I can't find my little trimmer tool, and it looks like clockwise to increase the bias, anti-clock to decrease, so we'll just bring that up to about 40 milliamps or so. That's plenty. I don't like to bias it too hot, so that'll be fine, and we're good to go. And that's how you bias the Engl Powerball. Not too much drama really. Well, there you go. I'm very, very happy about that one. It's not often I give myself a big pat on the back, but I do for that one, because that was quite an intuitive kind of repair from the track side of the board. We did get a bit lucky with the tracks being so obvious, you know, coming from that HT capacitor, a track going to the other HT capacitor which fed the grids, and we were able to kind of get some idea about what was under the board. But what a way to design an amp so that you almost literally cannot repair it. I'm seeing that more and more frequently, and it really does annoy me. So anyway, favourite in mine being the Fender Bassbreaker 15. I've done a separate video on that. Almost impossible to repair. So anyway, the customer's delighted on this amp, because he was going to write it off actually if I couldn't fix it, and I did it for a very reasonable price, because I was able to fix it from the top side and didn't have to get involved in taking that board out. Well, anyway, that's it from this amplifier repair, and thanks again for watching. I'll catch you on the next video.